over a couple examples with you really quick, just on the whole rational polynomial inequalities again, and then I'll let you guys start working on the homework. Remember, I didn't make a new homework assignment. It's just I made one for the whole section, and then it's kind of just due on Friday. So tomorrow, we'll have a meet, see if anybody has any questions, and you guys can just work on the homework if it isn't completed yet. And then over the weekend, maybe tomorrow, I'll have it ready to go. So if anybody wants to use tomorrow to get it over with, if you've completed the homework, you can. Like a short five-ish question quiz, just so we can end chapter 4 and move on to chapter 5 next week, okay? All right, here we go. So here are our notes for today. Here you go, Case. Sorry, I don't know why they didn't print out, so I have to write it in. So you're going to have to write it in real quick. Okay, so when we're going to solve a higher degree or rational inequality, we want the inequality compared to 0. So let's get everything to one side compared to 0. So I'm just going to minus this one over here. All right. Now, normally, if we have to solve the inequality, we need this to be one rational inequality. I need these fractions to become 1. So I'm actually going to have to subtract them. So we're going to have to find a common denominator so we can subtract our fractions. However, it's easier to find a common denominator when the denominators are in factored form. So I'm going to factor this really, really quickly. Just pull out the GCF of 3. So really, it's 2 over 3 times x minus 3. All right, so now let's get a common denominator. What does this denominator need factors of to look like this denominator? He needs factors of 3 and x minus 3. So I have to times top and bottom of this fraction by 3 and x minus 3 to make them common. What does this denominator need a factor of to look like this denominator? He needs a factor of x minus 2. So I have to times top and bottom of this fraction by x minus 2. And then we'll have a common denominator of 3 times x minus 3 times x minus 2. All right, so on top over here, 3 times x minus 3 times 1 is just 3 times x minus 3. Then I'm going to have to subtract 2 times that. And then it'll all be over that common denominator of 3 times x minus 3 times x minus 2. And it still needs to be less than 0. All right, well, our denominator, we want to leave that in factored form because we're going to have to find those bad numbers. But in order to combine the tops, I do need to distribute and get rid of those parentheses. So I'm going to end up with 3x minus 9 minus 2x plus 4 all over 3 times x minus 3 times x minus 2. And it still is less than 0. All right, let's figure out the top. I'm going to get x minus 5 over 3 times x minus 3 times x minus 2 less than 0. So guys, now we're in business. Now, this is the inequality we have to solve, right? So now let's find our zeros. What's going to make the top equal 0 and be the cutoff between a positive and negative number? 5. And then what's our domain? Who are the bad guys that still act as these critical numbers that we have to put on this number line? X cannot be 3 or 2. So now your zeros and your domain are the numbers that go on your number line so we can test the behavior around them. So we got 2, 3, and 5. Now, which numbers do I want to include and who can I not include? Well, I'm never going to include the bad guys. They're never going to be allowed to be answers to this problem. So they're always going to be open circles. Now my 0, he could be included as an answer provided I want this statement to be a number less than or equal to 0. But I don't want to be equal to 0 here. I just want to be less than 0. So I don't want to include 5 either this time. All right, and then we're just going to test numbers in between and find the good and bad intervals of x. Everybody okay? Good? You're okay, Case? All right, so I'm going to go with 1. So if I plug 1 in, that's going to be a negative number over a positive over a negative and a negative. So guys, that's going to be a negative number divided by a negative number. I'm sorry, a negative number over a positive number, which will end negative. And then will a negative number make this true? Will a negative number be a number less than 0? Yes, it will. So these are good intervals of x. All right, let's go here. Now I'm going to test, I guess, 2.5. All right, 2.5, that's going to be negative, positive. 2.5 minus 3 is going to be negative, and then 2.5 minus 2 will be positive. So guys, that's going to be a negative over a negative, and then that's going to end up as a positive number. Will a positive number make this statement true? Will a positive number be less than 0? No, these are bad guys. And again, there wasn't that bounce at that multiplicity, that even multiplicity here, so it should change sign. All right, now I'm going to go for 4. I'm going to get a negative, a positive, and a positive. So that's going to be a negative number divided by a positive. That's going to stay negative. And will a negative number make this true and be less than 0? Absolutely. These are good x's. And then the last one, I'll test 6. Positive, 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 positive. It's a positive over a positive. So will a positive number be less than 0 and make this statement true? No, these are bad x's. Actually, yes, these. Okay. All right, so now all we have to do is name the good intervals of x that make this inequality true. And those are x's on this interval from negative infinity to 2, but not including 2. And then union, these are bad. The good answers don't pick back up until 3, and they go till 5, but not including 3 or 5. And you're done. How do we feel, okay? Like I said, I feel like coming off of those graphs, this actually feels pretty good. It's a nice process that we kind of get to just go through the motions again, all right? All right, let's try one more, and then you guys are going to be good for today. Not that it matters, but I'll keep it up anyway. I'm pretty sure there's a question like this on your homework where we're kind of asked to find the domain again. And remember, when we're finding domain, we're looking for 2 bad things that could happen to this function. We're looking for x's that go in that cause a 0 on the bottom of a fraction, and we're looking for x values that go into this function that make a negative number come out of come under an even root radical. So we don't want those 2 bad things to happen. So in my eyes, I right away see both of those conditions can kind of come into play here. Right away, I know this is a fraction, so I know I never want the bottom of this fraction to be 0. So I know one condition is that x can never be negative 4. Right off the bat, I can see that. And I know whatever is underneath this radical, which is x minus 2 over x plus 4, I know that can never turn into a negative number, because then I'd be taking the square root of a negative number, and that's going to bring in imaginary numbers, and we don't want that. So now I know what's underneath this radical has to stay positive. So it's got to stay bigger than 0. Is it allowed to be 0? Can I take the square root of 0? Yeah. So I know it's allowed to equal 0 as well. So again, this condition will probably get covered here. I just like to cover my bases that I'm acknowledging. I know I never want the bottom of that fraction to be 0. All right, so guys, now you have a polynomial rational inequality here. You have to solve this inequality. So luckily, it's already compared to 0. So now let's find our zeros. Let's find our domain. Let's put them on a number line, and let's start testing numbers. Guys, I'm going to let you guys do this one. I'll do it up here, and we can kind of keep checking in. But let's see if you guys can do this one. So let's get our 0, which would be x is 2. Let's get our domain, which we kind of already said already. X cannot be negative 4. And now let's put those two numbers on a number line, and let's see if you guys test. All right, remember, we never want to include negative 4 as an answer because he's bad. 2 we can include if we're allowed to equal 0, and we are allowed to equal 0. All right, you guys test. We got 3 intervals. We got x's here, here, and here. I'll test them here, and you test them there. How'd you do, Case? Okay? I don't know if you guys are looking at the same as me, but right now I'm looking like I have a good interval, a bad interval, and then a good interval. And then just remember, we want to remember that negative 4 should never be one of our answers, and that 2 can be an answer. So in some way, shape, or form, make sure we're showing that. So my good intervals are negative infinity to negative 4, not including negative 4, union, pick up at 2, but include 2, and then go off to infinity. Okay? All right, guys, how do we feel about that? Everybody feel okay? Good? All right, great job. I think then, other than on your homework, I think it starts just by giving you the graph, and you just find the ones that are greater than 0, less than 0, just looking at the graph, which to me is even easier. All right? But other than that, I think then you should have seen about everything on the homework now. So again, tomorrow I'll let you guys work on the homework, and maybe today I'll try and get that quiz made ready for tomorrow. So if anybody wants to use tomorrow to get those few questions out of the way, then that's great. And then, like I said, I'll try to leave it open over the weekend as well. That way, nobody feels rushed since you just took that quiz on Monday too, all right? All right, if you have any questions, you can hang out and let me know. Otherwise, I'll let you guys go and start working.